Welcome back. Rational versus irrational, Unit 6, Lesson 1, Part 2. Rational versus irrational. I know I don't have a video up this time. I've been noticing that it's been kind of covering some stuff, and it's kind of hard to figure out a solution to that. So we're just going to go with no video for right now. Rational versus irrational numbers. We have a little chart here. For those of you who are taking my class, I need you to focus on these because this is going to be a quiz. This will be a quiz, and it will be all from memory. You will have to know these perfect squares from memory. These are square roots. Okay? In square roots, there are rational and irrational numbers, but perfect squares are rational numbers. And these are all rational perfect squares. Square root of 49 is 7 times 7. 7 times 7 is 49. Square root of 36 is 6 times 6. Which is 36, okay? That's what a square root is. A square root says what times itself equals that number. So what times itself equals 9? Well, 3 times 3 is 9. What times itself equals 361? 19. 19 times 19 is 361. But again, this part from 1 to 12, the square root of, is going to be a quiz for my class if you are in it. So classify each of the following in a T-chart. What that means is that you're going to have two sections here. You're going to have rational and you're going to have irrational. It's going to be very similar to your practice later. What you want to do is find the numbers in here and classify them. Are they rational or irrational? Remember, rational numbers can be written as a fraction. Irrational numbers do not end and do not repeat. Go on forever. Okay, so let's do a couple examples here. Then we'll let you pause the video, come back, and check out and do what you're supposed to do. Okay, so -4, that is irrational. It terminates, it does not repeat. Same with our next one, 2.97. It terminates, it ends, it has an ending point, and it does not it does repeat if it does. Okay, 7/9, that's a fraction. I can write that this way. That actually would, if I divided that out, would be 0.777, and it would all repeat. Okay, we did that one. Okay, let's jump around. Let's find an well, let's look at this example here. 6.3 repeating. So that's like 6.3, and it keeps going. It never ends. However, since it repeats, it is rational. How about our next one? Pi. Pi is irrational. It goes on forever and it does not repeat. What about square root of 36? Is that a perfect square? Well, let's look at our chart. Perfect square, square root of 36. So that's going to be rational. Let's check this one. Is square root of 76 in there? Well, let's see, 36, 49, 64, 81. It would be right here, but it's not a perfect square. Since it's not a perfect square, it's going to go over here. 2 times pi. Well, if you have a number that continues on forever and never repeats, and you just make it bigger by 2, you double it, you're still going to have a number that goes on forever and does not repeat. Hey, I did quite a few of them. Pause the video, see if you can come back and figure out the rest of them, and then come back and check your answers. Okay, let's put the rest of them in here. 189 terminates. Square root of 121, we check up here. Square root of 121. Oh, there it is. It's 11. So that's a rational number. Square root of 23. 25, 16. Nope, no square root of 23. So square root of 23 goes over here. -13/5. That's a fraction. -13/5. We can write it over here. We have a terminating decimal. Terminating means it ends. We also have a terminating decimal, means it ends. Square root of 1, is that in here? Oh, yes, it is. What's 1 times 1? 1 times 1 is 1. Square root of 0.49. Well, notice that we don't go down that low, but what's the square root of 49? That's 7. If I just make it into a decimal, it's just going to be 0.7. So this square root of 0.49 is going to be on this side. Square root of 60. Well, I got 64, no 60. So square root of 60 is on this side. And then lastly, square root of 10 over the square root of 2. Well, what's the square root of 10? Look up at our chart. It's not in there. 9, 16. So this top number is irrational. And this bottom number, square root of 2, isn't in here, is also irrational. And if you ever divide an irrational by an irrational, you're going to get another irrational number. And I know that looks like a fraction, but that's really just a division problem. So you need to figure out that part. And that's it. Summary here. Rational numbers. They are repeating. Oh, try that again. Repeating. Yeah. And they are also a fraction. Irrational numbers are never ending, and they are not repeating. And that's it. Unit 6, Lesson 1, Rational versus Irrational. Just identifying what type of numbers are rational, what type of numbers are irrational. Hopefully that helped out a little bit. If you have any questions, comment below. Thank you. Have a great day.